Hello, everyone. This is Carolyn with ID Additives. I am behind screen, but just wanted to give a few things before we start. If you can mute your computer while Ron gives the presentation, that'd be great. And then after he is done, we strongly encourage questions, stories, comments. We definitely appreciate the interaction. I will be behind the screen, as I said, and you can send any questions via the chat or any questions also about Zoom or any technical difficulties. So with that, I am going to mute myself and I am going to pass it over to Ron.
Now, hello, everybody. Welcome again to our Zoom chat. Today it's a little different than last one. It's foam and fill. It's really foam and or fill. So with foaming agent, it is a filler. Calcium is a filler. The difference between the two, calcium never goes away. You put in 10% calcium, you're going to get 10% less material in your part. With foaming agent, it'll go away. Then bubbles can be collapsed. So the process is really important, whether it's thin wall, whether it's cups, whether it's a cap. All the processes are kind of similar in process, but today, look, I can talk about foam till I'm blue in the face. I've done foaming for 30 years. I've got so many stories, it's ridiculous. But what I want to do is I really want to target some of your applications because not every application is the same. Machine capabilities, injection velocities, temperatures, control the bubble. All that stuff comes into play depending on what you want to do. Non-aesthetic parts, which means there's splay everywhere. They're kind of easy to do, but just because there's splay on the surface doesn't mean it's foam. It just means you got a bunch of splay on the surface. So whether it's non-aesthetic or aesthetic, the process is kind of the same. Temperatures change, depends on percentage of barrel that you use. I think the combination between a calcium and a chemical foam, they work really, really well together. Some parts, because of splay, because of machine, you know, maybe not all parts are a good fit for a foaming agent. That's why we would recommend a filler like calcium or talc, or you know, just a filler to pull out some of that polymer. But the combination of the two, great nucleating sites for the foam, makes the cell structure much smaller. And when you add that 10%, now your weights go up. But if you add foam with it, you can actually pull the weights back down and you still get a stiffer part, more rigid part, and the cell structure is amazing with calcium. And so I really want to focus. I mean, I've done caps. This was injected like 0.2 seconds. These were injected at like 0.4 seconds, 0.3 seconds. Highly aesthetic, no foam on the surface. Everything's just a beautiful gloss surface. Cell structure from here all the way up. This is PLA, very heavy material, took 30% out of it, weight. And that was unbelievable. I've got a customer that's doing extrusion blow mold, and they, you know, whenever you do bottles things, it's got neck pressure, right? That neck has to withstand. Well, I recommended some calcium along with foam, just to give them a little better stiffness, a little more rigidity. Plus they pull polymer out. They work great together. If foam splays, and you can't really run foam without having, you know, visual effects that your customer may not like, and the machine just isn't capable of doing a very high gloss surface, then I would highly recommend calcium. And I always do to our customers. You want to pull that polymer out. You don't want to put too much in there because then it starts to get brittle. So you got to kind of watch how much you put in. But everybody, look, these days, it's a little crazy. Some people can't find material. When they do find material, it's like ridiculous in cost. And we're getting people from all over the world asking us about our foam. And look, foam and agents come a long way over the years. Back when I first started in the mid 80s, there's no way I could have foamed this part aesthetically. No way. You'd had splay all over the part, probably very little bubbles in the middle to begin with. So it's foam and agents come a long way, and the process is more important than the product. People don't take advantage of the foam. They drop it in and they get splay, take a little bit of weight out. It's all good. But temperatures are really super important. Endothermics, especially injection molding. And this is what I want to target today, injection molding. If anybody has any questions on extrusion, extrusion blow, structural foam molding, multi-nozzle structural foam molding, I'd be happy to answer any of those questions. But I want to target injection molding. Last Zoom chat I had, I mean, I hit all these different applications and never really focused on one. And I mean, this is not going to be my last Zoom chat. I want to kind of stick with injection molding. Then the next Zoom chat will be on extrusion and just kind of move on from there. But I'm happy to talk to anybody about any of their applications. And the idea of this Zoom chat is really to get enough information that you're interested in and to ask a question or set up a Teams meeting with you and your team to discuss specific applications, machine capabilities, temperatures, all that stuff, resins, and then develop a plan to foam that part. Now, we're traveling now. I got both my shots, so I'm starting to travel, starting to do trial runs. So really, I just want everybody's kind of heard about foam. Most everybody knows a little bit about the foam and what it does. It does a lot more than what people realize. I am, as many years as I've done this, I still get surprised on how it performs in some applications. I did a thin wall. It was 28 thousandths wall not too long ago. I took 13% weight out, which is, that even surprised me. But it worked out really well. So we really want to get to the point where you're asking questions or you want to set up a call to go over your application, because your application is different than the vast majority of applications. Everything is a little different. Process-wise, it's still low pressure. You still want to keep everything moving. That's residence time. Whenever you're running foam, you always want to get that screw back just before the mold. You don't want that gas in the rear, it disappears. So you don't want to have it set back there forever. I did a trial run and they had over 100 seconds delay time. We took that off and we slowed the RPM down to where it was creeping slow. But man, did it foam well. They went from a little bit of foam here and there to just a massive amount of foam just because we took the delay off. And that kind of tells you what happens to that gas. It disappears up the hopper. And believe me, you're paying for this stuff. We want to make sure everyone gets the most out of it, and that it's done to where you control the bubble with temperatures, with injection velocity, and again, it's low pressure. Let the foam do the work. And thicker parts tend to be a little easier to do aesthetically, only because it's a thicker part. You don't have to inject it in as fast as you would something like this, opposed to a thick part like that. Big difference. But injection speed is the key. The faster you get it in, the more weight you're going to pull out. Now, you're obviously going to pull weight just by taking your pack pressure down. But the key to light weighting when it comes to foam is speed. So again, foam isn't for every application. I personally feel like I need to foam it before I make that distinction, or have at least a good conversation to find out what's going on with the, how their machine performs. how many shots are in the barrel, is it multi-cavity? You know, when you talk about multi-cavitations, again, bubbles can go away. Calcium, you add calcium, it never goes anywhere. You put 10% in, you always get 10%. That'll never change. The foam, the bubbles will go away. So that process is really, really important to get it in quick and let the foam fill the part out. So at this time, does anybody have any questions? Any kind of resin? I mean, I've foamed ethylene, propylene, styrene, Z-noise, acetal, Narelle. Probably, actually, I'm going to foam some Ultem, which I've always wanted to do, and I got an opportunity to foam Ultem within probably this week. So I'm really excited about doing that too. So there's not much I haven't foamed, and I've failed in a lot of areas, but I just continue to learn how to optimize that foam because again, you are paying for it, and we want to make sure that you're getting everything out of it. So does anybody have any questions at this time?
This is Mike Green. Got a question. Have you ever run with HDPE, the Dow DD6200?
That specific grade, probably not sure. I foamed a ton of HDPE, ton of polypropylene, you know, from frac melt to like a 35 melt. It does, you know, foam really doesn't care what the resin is. If the foam can expand in it, it's going to foam it. That's, and you know, I've had people come up to me and, well, what about this particular resin? Well, I literally have to look it up. I'm not familiar with all the different resins, but this is what I tell people. If the foam can expand in that polymer, we can foam it. And if we can't foam it, we can fill it. Is it correct at low pressure, low injection speed? Low injection speed. Low injection, low pressure is correct. I can tell you right now that 99.9% of everything I've foamed in the last 30 years has 0 holes, 0 pack pressure. None. The gate freeze is not pressure and time, it's just time. So you use the pack time. Low injection speed and no delay time. No delay time, agreed. Low injection speed, no. You want fast injection speed. As fast as every trial I go to, whatever that machine will do, I'm going to do it. But for the polyethylene, I'm sure we can foam Dow. I've foamed Dow materials. I don't see any issues with that high density polyethylene.
Do we have any other questions?
Okay, so yeah, endothermics. Endothermics is for injection molding. So when you do foam apart, everything's gone off. There's no particles in there that hasn't gone off. They've all gone off. And we have customers that literally grind up parts and put it in a high aesthetic part. Remember, if you don't change your process and you go into the pack and hold pressures like you would normally mold a specific part, that foam, you're going to pack it. If there's any residuals, which there's very few, if any, you're going to pack it completely out. You're not going to see anything in the wall. You're not going to see anything on the surface. That foam, especially in the rear zone, when that polymer melts, all it is CO2 gas that escapes. It's not a pellet that has to decompose and then go off. It's already decomposed, already bubbled. So we highly recommend you do not throw that scrap, grind it up, and throw it in another application, and you should be just fine. I hope I answered that question. Mr. Ferguson?
Ron, you mentioned about having video chats with individuals about their process and stuff. How would we go about scheduling something like that?
Oh, scheduling a trial run?
Well, no, in my particular instance, I already have a sample. I know the machine we're going to run it on. My two processing experts have finally come to the conclusion that resistance is futile. I'm going to press them till we try this stuff. Okay. But we would probably be light years ahead if you would talk to them and give them experience and tell them, hey, here's what you got to look for. Here's what you can expect. And they could go over with you. Here's how we normally run. And you can give them pointers on how to be more successful.
Yes. And I do Zoom trials, FaceTime, WhatsApp. And I actually would rather be there than to do that. But we always recommend, if you guys, anybody asks for a sample or anything like that, before you run it, we always want to have a Teams meeting with your tech team to go over temperatures, go over their process. And I actually like to go over that. I do have a questionnaire that I send out, and it just basically gives me an idea of what you guys are doing. And it gives me an idea what product we can send to you. But a call is always good, so everybody is on the same page when it comes to processing this. And if they have any questions, then that's the perfect time to ask questions to get these guys understanding the low pressure process in a high pressure machine.
Yeah.
And what you're, the aesthetics is important. What you're looking for aesthetics. If aesthetics is really important, that machine capability is very, very paramount. Very important. That speed is everything when it comes to aesthetics. So, yeah, we highly recommend sitting down and talking to people.
Okay, I'll try to arrange something.
That number, we have a number, we didn't have a number. Always number.
What's that?
I don't know. Whatever.
No effect
There was
on foaming on recycling, i.e. foam parts can be recycled the same way as uniform. No, it doesn't. I mean, if you take your regrinds and you want to get it reprocessed, so to speak, during that process, all the gas is gone. Again, all it is bubbles at that point, and they run it through pelletizer or anything like that for repro. They typically have 1 or 2 vents. If anything gets past that rear zone, it's out the vent. So when it comes to reprocessed material or regrind, they foam a lot better than virgin material. And not sure why that is, but I know that, if I'm running 100% regrind, it foams extremely well. And I think mainly because it's seen a history of heat. And so it breaks down a little bit, so it makes it a little easier to foam. But yeah, definitely, we have customers run 100% regrind, and it foams beautifully for them. So definitely, and when you add foam, I had a customer running Xenoi, which is a pretty tough material for them. They couldn't fill the rib. They added foam. All of a sudden, the rib filled. So it will open process windows up. It will improve flow. And if it does that, now then you look at your temperatures, right? I mean, if foam changes the viscosity of the material, there's only one other thing that does that, and that's heat. So now you have to ask yourself, do I need the heat now that I'm adding foam? Do I need heat? And you don't. I did an extruder test in out Atlanta. They're running 480 top temperature down to 420 in the rear. I mean, it was like pulling teeth to get them to drop those temperatures. But today, they're running 385 in the front and 320 in the rear. And it's foaming like crazy. So the viscosity change is very evident. So take advantage of that. Pull heat out of the barrel, control the bubble, get it in quick, let the foam pack the part out, keep the residence time tight, slow the RPM down so it gets back just before the mold opens, inject fast, and that's basic foam process. Temperatures change, only depends on what they're doing. Go ahead.
We have another question. It's, do we need to adjust foaming agent concentration based on regrind percent?
No. When you're running regrind, if you're running 1% foam, you stay with 1% foam. If you're running regrind that's foamed, you still stay with 1% because you're going to lose a lot of gas out the rear. Even with a low residence time, you're still going to lose it because it's just gas at that point. It's not a pellet that has to decompose and then start to go off. It's already gone off. So yeah, you shouldn't have to adjust the foaming agent when you're using regrind, and it should foam a lot better with regrind. Perfect.
Does the foam meet regulatory standards for food grade applications? Any impact on taste and odor?
Yeah, we do. We have FDA certs for this product. We actually mold parts that have direct food contact. So yeah, we're not worried about any of that stuff. And odor wise, I haven't noticed any odor in it. It's CO2 gas is all it is. Yeah, we are working on NSF on a few different things. We got some, but we're working on other NSF products.
Good interaction, everyone. Anybody else have any other questions? Oh, we do. Oh, we have a few questions. Hold on one second. How does foam work on PCR?
Okay. I had to get the abbreviation right. Post-consumer regrind. Works great. Works great in any regrind. To determine the product that we want to use is whatever regrind the material. We have foaming agents for nylon and polycarb, non-hydroscopic. Regrinds, it's typical endothermic. Not a problem. On multi-layer continuous extrusion, is there a preference to run the foam in the inner layer or skin of the parapet? Yeah, I mean, if you got multi-layers, you can definitely foam the inner layers. If it's just a mono, which is most of the stuff that we do, it's a mono layer, it foams really well. And again, you don't even know it's in there. It hides very well in the wall. And we've seen some great stuff on that in multi-layer extrusion. On the extrusion blow mold, the key to that application, and look, my forte is injection molding structural foam. I've learned a ton about extrusion blow. Extrusion blow molding, the key to that is blow pressure. When the paraffin drops and you're using, let's say 90 PSI and you're blowing it out, well, you're packing the part out as you're blowing it. So you're going to find that when the paraffin drops, the viscosities change to where it blows out much easier. You don't need those pressures. We went from like 90 to like 38 PSI, low pressure. That's huge. And that's any more than that, you'll pack the bubbles out. Now, if you add calcium, again, that don't pack out, so you can still pull. One of my customers, they wanted to wait so that they could add more calcium. I was thinking, okay, doesn't matter to me, So they were able to boost from 23 to 33% calcium by adding foam. So it'll help make room for other fillers if you need to. So that's
Have you done?
just extrusion blow.
So the next question is, have you done strength testing? How do the gas voids impact strength on ribbed and non-ribbed parts?
Okay, for the strength test and stuff like that, everything has to do with how much material you pull out of the part. You pull out 15% of material out of the part, believe me, it's going to affect the structural integrity. It's going to affect a lot of things. But, this is why we have conversations with people. We want to know, well, do we want 8%? Do we want 10%? Where do we want to go to where you save money and yet it still passes all your impact tests and things like that. So usually there's a you know, a plus or minus. And a lot of times when people are molding parts and they have that plus or minus range on impact, they're up here. They're up there. But what we do is we want to bring it down, not to the bottom, but bring it down to where you do pull some weight out, you do pull some cycle out, and it still, handles all the impact requirements that are needed.
Okay, next question is for blow molding. What are the key parameters for good foaming? Tips and tricks.
Okay, temps are important when it comes to any foaming agent. Again, in extrusion blow or extrusion, those temperatures are so important to control it. And now that we're getting into kind of extrusion here, you want to add screen pack. You want to get that head pressure up. And what that does is it creates pressure on the material in the screw. So remember, foam, if it's not under pressure, it's a low pressure application. So it sees a low pressure, it starts to expand. But if it's under pressure, it doesn't want to expand. And that's ideally where you want to be, because you want it to expand when it exits the barrel into the die. As soon as it exits the barrel, you're going to see a drop in pressure. It's going to start to go off. If you've got a melt pump, there's a drop in pressure. It's going to start to go off there. But I prefer it go off there than way back at the back of the barrel. So those pressures will allow you to add more foam and keep the part aesthetic. Whereas if you're pre-foaming a lot, you're going to get less weight and you've got to use less material because it's pre-foaming, it's getting out of control. So I hope that helps. Okay.
Next question. Is there an additive or chemical material that we can use to reduce the temperature of additive decomposition?
So you're talking about our materials? I mean, as far as decomposition, we have materials that kick off at 325. We have materials that kick off at 380. We got materials kicking off about 420. So we do have a range of products that kick off in different temperatures. I hope that's what you're asking. If it's not, please let me know.
Okay, so next question is, if you run EBM with lower blowing pressure to keep the foam, don't you lose definition in the sharper corners?
Yeah, not necessarily. I've done very, very sharp corners with foam. Again, like I said before, 99.9% of everything that I've ever foamed, I use no pressure. Look, that pack is full, right? So in some cases, it doesn't mean I never use pressure. Sometimes I have, I like to leave the back pressure low, but sometimes I have to bring that up a little bit for, consistency shot. But yeah, it's just, what was Carolyn? Question? Can you back up to that? I want to make sure I get it all right. Yeah, not necessarily you lose the definition of the corner, but again, we really have to run it to see. I've had really nice tight corners with foam, and then again, you're right. I've had some that doesn't make that real sharp 90, but it's the applications we have to look at before we decide this is not.
Okay, do we have any other questions? Oh, we do, okay. If you want to foam FR ABS, would it affect flame resistant properties?
It will not. I've actually molded some pallets years ago. They stacked them up, did the burn test, and it passed using the foam. The foam, it doesn't affect UV. It doesn't affect really anything. All it is bubbles you're putting apart. It doesn't take away from your FR content in your material. I mean, I'm currently foaming FR2, so I'm not really worried about that.
To go back to the foam decomposition, we're adding on to, in the past, we used zinc compounds to enhance foam material decomposition. The question, is this applicable in any respect with your standard foaming agent?
Not to get into any stuff, but zinc is a kicker, right? So I'm not sure if we have zinc in our materials or not, but we do have kickers that allow it to go. And that they are important because you want it to kick when you want it to kick. It does. It, you know, as a nucleating agent and chemical foam are two different animals. Nucleating agent, you know, chemically crystallizes the material, where the foam, what it does is so, you know, back to nucleating agents of foam. You know, foam, it allows you to bring the temperatures down. It allows, it's an endothermic reaction which pulls heat. So it actually crystallizes the material sooner than without foam. But a nucleating agent is, it chemically crystallizes it, and that's kind of the difference between the two. And that, you know, the percent just kind of depends on what you're doing, I guess. Oh, it does act like a nucleating agent, but it's a whole different animal than nucleating agent. And optimal percentage is going to depend on what you want, what you're looking for in whatever mold or application you're in.
Great questions, everyone. We really appreciate the interaction. Oh, we have another one. Are these additives suitable for PU and PVC shoes, soles, injection molding?
Yes, yes. I think we are currently doing that on shoes and soles. So yeah, it works great with PVC, polyurethane. It foams very well.
We have another question. What's the difference between endothermic and exothermic foaming agents?
That's a good question. They're obviously two different animals. One gives off a nitrogen gas, which gives you an exothermic reaction, and exothermic reaction generates heat. And if you used to look at the two side by side in a graph, an endothermic, it goes off in a slope, an exothermic starts off, and then boom, you get it all at once. So in injection molding applications, I would never recommend an exothermic. I'd always recommend an endothermic. The only application I'd use an exothermic in would be like rotational molding, extrusion profile, and but the two endothermics, they absorb heat, and they're more FDA safe than the exothermics. Exothermics, there's none that I know of that are FDA. I would not use an exothermic in injection molding because you want to try to pull heat out, and that exothermic is adding heat. And then it's kind of tough to control that bubble when you get it all at once. So I never recommend an exothermic in injection molding. Not that I haven't used one. There's very few applications that will work for it that would do a good job with an exothermic. And You know, we do have endo exos for any application you guys might have.
So to add on to,
That
you recommend endothermic foaming agent for IM and BM.
I do. I recommend endothermics for that. It's the right way to go, especially for extrusion blow. We had a customer do a little bit of got a little bit of data on extrusion blow. We found that 14% of the temperature of the part was the part temperature was 14% cooler when they added it. So they could see a cycle reduction because of the endothermic reaction that it's doing. So definitely endothermics for injection molding, extrusion blow molding. They work really well. Premature wear on barrel and screw. It is a semi-lubricant. So if it's going to change the viscosity of the material, it should improve flow. It should have less wear and tear on your equipment. Remember, you're using low pressure, so there's not a lot of pressure against the mold when you're injecting it. At higher speeds, you end up bringing pressure up, but still, it's still low pressure. You're not packing it. It fills the part, and I've had parts where they've had flash, and we've added foam and virtually got rid of it. And that metal was hobbed, it was hobbed over, and we virtually got rid of it. I mean, there was just a little, with the hob, you're going to get a little bit there, but I mean, they were flashing that far out, and we took that down to virtually nothing. So absolutely.
To add on to the shoe sole question, it's they're saying that it also includes a calcium carbonate filler. So maybe you want to touch on kind of using both.
Yeah, I mean, you definitely want to, again, depending on the application for the foam. Again, foam isn't for everything, but that calcium, you can run it in just about anything. Ethylene, propylene, foaming agent and calcium, they work really, really well together. So you go 10% calcium, you're going to add weight to the part. So foam, the calcium creates nucleating sites for the foam. The bubbles are extremely small, and they just perform really well. And you can still lower temperatures with high loads of calcium and still get a good flow with foam.
Awesome. So next question is, could Telc cause wear on screw and barrel?
Talc is rocks. Calcium is rocks. I mean, if you go really high on the calcium, high on talc, it's going to wear your screw and barrel. I mean, it's obviously going to wear a little. I don't know how much, but just kind of depends on how high the level of filler that you have in there. We do as high as 68% calcium, and it does wear the screw and barrel. It does, but it does open the process window for that particular part. So yeah, I mean, calcium and talc over time will wear your screw and barrel. It's rock. Can't help it. Kind of like glass. Same thing.
Next question is, any concerns on foaming highly cosmetic / high gloss PP parts?
Mm-hmm. We do a lot of high gloss surfaces, Class A surfaces that you would never know the foam is in. This cup is polypro, and I don't know if they can see this very well, but this cup has bubbles from the gate all the way up. Just solid mass of bubbles. Mass, you can't see through them, but you know they're there. You got to use a jeweler's loupe to see them. But this surface is a mere finish. There's no splay. And that's part of the process. If you want to do high aesthetic parts, you've got to get it in extremely fast. The faster, the better. So if you just wanted to do an aesthetic part and I come into your facility, I walk up to your machine, if you're injecting the part at, I don't know, 4 or 5 inches per second, and you could do 10, I'm gonna push to that 10 inches per second. Faster, the better. The faster, the lighter. The faster, the more aesthetic it'll be. I mean, you can go, this cap right here is a 28 thousandths wall, and it is highly aesthetic. There's no splay anywhere on that part, and the bubbles are loaded in the wall. So, yeah, we can do very high gloss, Class A surfaces, and people, you add any color, you'd never know it was there.
All right, here's the question I think you've been waiting for forever
I don't
is
know.
what's the key to form tiny foam bubbles?
Temperatures, right? If you think about it, foaming agent is activated by temperatures. The hotter the temperature, the bigger the bubble. So you want to control that bubble, because if you start getting crazy bubbles, that means you're pre-foaming, you're having a lot of trouble. So temperatures keep the foam down, speed, no pressure, but the temperatures are the biggest thing for bubble size. But when you add calcium with foam, it makes the bubbles even smaller. I mean, it just works really, really well.
This is back to the shoe sole question is there a need to include foam stabilizer additives in the process?
With our foam, I don't think you need that. But again, not 100% sure. I really don't think you need that. I mean, our foam's pretty stable. Your process really is what stabilizes the bubble, the size of the bubble, the weight of the part, the cycle, everything. It's just so important.
Okay, which is the maximum calcium or talc recommended?
That's kind of up to you, how much you want to pull out of it. Brian, is there a recommended calcium LDR that you would start with? Loading? $10 to 30% range? Okay, on an 80% calcium concentrate? Yeah. So anywhere from 10 to 30, again, I'm just telling you, we currently foam a 68% calcium. 8 to 25% in the final part. Yeah. But it just kind of depends on how much material you want to pull out.
Next question is any experience foaming glass-filled nylon or PBT?
Yeah. Foam both of them. Nylon foams extremely well. So with nylon foams really well. So does polycarb, and I do have some polycarb parts here. But nylon and foam, and polycarb, they foam extremely well. A little bit goes a long way. But yeah, I have foamed a lot of polycarb and a lot of glass-filled nylon. Nylon 6, nylon 6.6, up to, I think, 30% glass-filled. Actually, I'm going to do a trial tomorrow on a 20% glass-filled nylon, and just to help push out some sink. So I'm excited about that. The nylon foams really work. I don't see any issues with nylon.
Next question is, does foaming agent affect filled nylon, PBT, or PC mechanical properties?
Well, if you've got these materials, your foam, you've got fillers in them, like glass fill, anything like that. The foam's going to open the process window up for that, number one. It's going to fill a lot easier. Depending on what you want what you want done, right? If it's aesthetic, it's a different animal. If it's non-aesthetic, then that's a different animal. But as far as foaming is, they foam very well. PET, nylon, polycarb, PCABS, we foamed all of them very successfully.
Just someone sent in just a comment. Calcium carbonate increases the density. Be careful with the PP and PE for recycling reasons.
Yeah. If you're going to run the recycling back out, and you've got calcium in it, kind of want to know how much calcium you're going to, if you're regrinding it or reprocessing it, that can be an issue.
Next question is, have you done any electrical applications and does it help with resistance?
We're doing, cable and wire. We don't see any issues with that. Electrical box, I don't see it affecting anything, to be honest with you. I just don't.
And then to piggyback off of that question, does foam affect electrical isolation properties?
I'm not sure on that. I wouldn't think it affects much, but I don't think it'd be a big issue on that. Of course, like I always say, gotta give it a go and find out. It's stuff that, I've done a lot of foaming. There's a lot of stuff I haven't done that I'm really excited about doing, once we get going with it. I'm not sure on that.
Next question is, you mentioned the exothermic created nitrogen gas. What type of gas does endothermic material
CO2
create?
gas. That's the gas. Nitrogen is an exothermic. CO2 is an endothermic. Nitrogen gives off an exothermic reaction, generates heat. Boom, you get all the gas at once. Endothermics go off in a slope. They absorb heat. And so that's pretty much the difference.
Ron, you've foamed a lot. What are some things maybe you haven't foamed that you'd like to? Applications that you haven't had a chance to try yet?
Ultem. I get to run some Ultem. I'm kind of excited about that. I've never done it. I've molded a little Ultem in the past, in my career, but I've always wanted to throw it in and see what happens. And this application is non-aesthetic, and I'm telling you, it's 700 plus degrees. It's going to go crazy, but it's going to be exciting. So it's going to be fun to see how that performs. They haven't, Ultem pushes so hard anyway, and they're having trouble filling the part. Aesthetics doesn't matter. So I'm really, really looking forward to doing that. That's another notch I can, something I've done. But there really ain't much I haven't done over the years.
Another question just came in. Away from injection, is casting or spraying a flexible or ridge PU coating? Is there a possibility to use any of your additives?
Yeah, I believe it is, because what you're doing is you're coating the actual part, whichever part that is. And by using an endothermic, if you used an exothermic and you were going to spray it, put a polyurethane coating on it or anything like that, it'll bubble up. Because exothermics take an extremely long time to degas. I've seen parts that take over 2 weeks to degas before they can paint it, because that gas just takes a long time for it to degas. Endothermic, they degas right away. So within minutes, you can spray it. It's all degassed. It's degassed pretty much before it even comes out of the mold. So yeah, I think you could do that with an endothermic.
Again, we really appreciate the interaction. We love the questions. Does anybody else have any questions? You can unmute your microphone if you'd like and ask, or you can keep sending them on the chat.
Yeah, homes insulation. I'm not sure that the in in the coating in the sprays, I don't think you could use a foam in that application. But if you are coating a particular plastic part that's injection molded, you could foam the injection molded part and then spray it afterwards. As far as home insulation, typically that's you blow foam in there. And that's a whole different animal. If like you're running 2x4s and 1x5s or whatever, you want to foam those in extrusion, that's fine. But actually adding it to a spray, no, it just won't work. It's got to reach a specific temperature to go off. And I've never tried it in that application, but in my mind, I'm just thinking, no, it's not going to work to insulate homes.
Another question just came in. Have you ever foamed a PET preform and then tried to reheat blow mold it?
Right. No, I have not done preform, but I would like to. I really would. I had an opportunity to. They were well, not. It wasn't an opportunity. They were talking about a little aspirin bottle, preform it, then then later expand it. I've always wanted to try that, but again, in the preform, the process is it's a thicker part, obviously, but the process is the same. You want that aesthetic surface. You don't want anything coming to the surface. So you want everything in the middle of that preform. So, injecting it fast, going the steps of processing that particular part. Then I think you can blow it. If it's not a see-through, if it's white or, if you color it, I think you can do it. I honestly do. I just haven't tried that yet. So I'm looking forward to it. Now, if it's a clear bottle or PET, a lot of it's clear. If it's anything like that, chances are it's not going to work because you're going to see the bubbles in the wall. But if it's a solid material, I think that's your best chance. Mm-hmm. Yep. Yep. Yeah, that's good call, man. Thank you. Yeah. So like in preforms, you'll foam it and then it goes in, and kind of similar to sheet extrusion when you thermoform it. You've got the sheet with all these bubbles, and then you have to heat it up, get that right sag, then vacuum it up and make a part, which we've done plenty of that in thermoform pallets and some other thermoform stuff that they're doing. On thermoforming and sheet, the draw length is important because you don't have, again, now you've got a cell structure in the wall, right? And then you're going to stretch that. And the further you stretch it, the tougher it gets. So if you're doing fairly short, I'm saying probably anywhere 6 to 8 inch draw, somewhere in there, maybe even shorter. The shorter the draw, the better it is.
I would like to mention in between questions, I did just send the link to our YouTube channel where this whole presentation will be on. And we have other videos, and we please ask you to subscribe. We are trying to get to 1,000 subscribers, and we are currently at 279. So just wanted to throw that in there, let you all
Ways to
know.
go. Come on now. You know, got a ways to go. Yeah, but what we really want is we want to talk to you and your team about any application that, you know, and a lot of stuff we can't talk about in this setting. But if you've got applications you'd like to talk to us about, you know, do you think the foam will work in this, or what do you think about this application? You know, we would love to sit down and talk to you guys about it. And again, I am traveling. I can come out to facilities and run. Got both my shots. So that's, you know, I don't mind doing Zoom and FaceTime and WhatsApp. I enjoy doing that because it's the best thing next to being there. But I really like to be at the machine to see all the intricacies of the part and how to go about foaming. We can do a lot of that over the phone as well. If I got a good idea of what your machine capabilities are, the wall thickness, shots in the barrel, those things are really important for me to kind of put together a process. You know, even a heat temperature, even heat profile, I can set up. Oh, yeah. I mean, it's a good point, Nick. Yeah, we could do this very same Zoom chat with your team. So your team could be there, and really we want everybody to ask all the questions that they need to ask. There's no such thing as a bad question. They need to ask those questions so that when we're done with the conversation, everybody knows what to expect. Everybody knows understands the process. So if they have any questions, you know, look, a lot of people have a hard time of wrapping around, you know, gate free pressure and time. Well, with foam, it's just time. So we definitely want to sit down with your people and go over the parts that you want to discuss, and then get you a sample. Hopefully I can come out, and if not, I can be at the machine via FaceTime, WhatsApp, you know, Zoom, however you want to do it. Or we could do a Zoom chat with your team, just like we're doing today.
Yeah, we did have a question. Do you ever come to Charlotte, North Carolina? And the answer is Ron will go anywhere.
Pretty much all of North America. Lunch and learn? Yeah, we do what we call our lunch and learn. And we can either come to your facility or have a Zoom meeting with everybody. You know, we buy lunch, we sit down with everybody, we talk about our different products and the advantages of our different products, and just see if it's a good fit for your team and your company.
We just had another question come in. Is foaming agent suitable for wood composite?
It is any filler. Depends on how much, you know, what the wood composite is. I mean, are you 60-40, 70-30, 50-50? And obviously, the more polymer. Now, you got to keep in mind, with all these fillers, right? Foam cannot foam calcium. It can't do talc. It can't do wood, glass. It can't foam any of those things. It only foams the polymer. So if you've got, let's say you got 50% wood, thank you for that, 50% wood, 50% polymer, then that foam is going to foam the polymer. It's not going to foam the wood. So 50% of that board or whatever wood composite you're doing, 50% of that is what the foam is going to foam. So 50% is 100% of what you're looking at as far as weight reduction. But yeah, we can. And with a wood composite, if it's injection molded, we're fine with that. If it's extrusion, we're fine with that too. Two different animals though, I mean, for each process. Injection molding, you'd use an endothermic. Extrusion, if you're doing a 2x4 or 1x5 or however you want, wood composite, wood lumber, that would be an Exothermic. It does improve flow. Yeah, it'll help the wood fibers flow, it'll help glass flow, it'll help calcium flow, it'll help talc flow. It will open the process window, and it will allow you to run cooler temperatures and still get. How much? We don't know until we understand what, the percentage of barrel you're using and how long. Let's say you got 5 shots in the barrel, right? So let's say there's 60-second cycle. That's 300 seconds from that when it hits the barrel till it hits the mold. And you got 5 shots in there times 60 seconds. That's 300 seconds. Yeah. I'm not good with math, but I figured it out. So all that time in that barrel, right? You think about that. Oh, you're going this way, then you're going this way, then you're going this way. Well, all that time there's heat, and the gas is going off. Example: I ran a nylon part, a Narell part, 2-inch shot, just like 15 shots in the barrel. They weren't getting any foam. And to think outside the box on that, I moved the shot size up halfway up the barrel, moved the transfer 2 inches in front of it. And what that did is, all it did was reduce the amount of time, that cup of material, before it got past the compression area. And they were foaming these parts beautifully after that. So, temperatures, if it's going to see that, your rear zone's got to be a lot cooler than what you typically use if you've got a lot of these shots in the barrel. Really, you got to prevent that foam from going up the barrel, and that takes a little bit to set up that heat profile so you get the benefit of all that gas, or the vast majority of it. When people say, well, I've got, 30% glass, 30% talc, what have you, and, we take 4% weight out. Well, 4% is not a lot, but when you look at the polymer by itself, it's actually higher than that. The whole weight is 4% lighter. But remember, when it comes to the wood, only 50% of that is what you're foaming. So actually, if you're looking at what you're saving in the polymer itself, it's more than 4%, if that makes sense.
Great questions, everyone. We still have an hour left.
Woo.
Yeah.
I got a lot of stories. I don't know if everybody wants to hear the stories. Yeah.
Ask more questions
Yeah.
so we don't have to hear Ron's stories. No, I'm just kidding.
Oh, well, Ron. Okay, so foaming agent is being used in, obviously, multi-nozzle structural foam. I kind of cut my teeth in that at Rubbermaid back in the mid-'80s, I guess. Structural foam molding, which is basically a multi-nozzle structural foam, pallets, bins, big parts. Injection molding with foam is just called structural foam. And those are 2 different applications, 2 different processes, resulting basically in similar results. But there's roto molding, which is typically an azo, injection molding, extrusion blow molding, extrusion sheet, extrusion profile, gas counter pressure, you name it, the foam. And look, just if you think that the foam isn't going to work for something, let's talk about it. It might just work, but we do need to talk with everybody and just sit down and talk about your specific applications. And foam is touching about every plastic application out there. And it's doing a phenomenal job. And nowadays, man, A lot of people need foam, or they need a calcium filler or something to take that foam away. Oh yeah. Yeah, this here, Nick, thank you for that. But Nick, this calculation here was when resin was 60 cents a pound. You can only imagine what it is today. It's off the charts. Fantastic. So, yeah, we're getting information. From all over the world is wanting to talk about foaming agents and what we can do for your specific application. That's kind of where I want this kind of to go, is that you and your team are looking at different applications. You're thinking, well, maybe we can use foam in this. So we definitely want to sit down with you and your team at your convenience and, talk about the applications you're interested in. Talk about what you would expect from our product and what you're looking for. And got to start a conversation, and then we can get samples out. Samples are all free. We don't charge anything for our samples. We just ask that people pick up the shipping. That's all. And just about any size sample you need, unless you get up in the high pounds. But, our samples are all free. So, and I do have a process guide for injection molding, and I don't have a process guide for structural foam multi-nozzle or extrusion blow for that matter. But I'm hoping to have something this year. I just have to sit down with some of our suppliers and go over the process. Again, extrusion, any kind of extrusion is the most difficult process there is. And there's people out there that's forgotten more than I'll ever learn on extrusion. So I'm always looking to learn more, to push the boundaries of our foaming agent in applications that maybe nobody thought of before. So that's kind of where we went. So we have, oh yeah, for the extrusion profile, we do have a liquid azo that liquid works. I'm a firm believer in liquid. I mean, they disperse quickly in the extrusion application. Man, if you got the app, we can set up a pump for you and all that stuff. We can bring it all out there and run a trial or whatever with liquid. But that liquid, I'm a believer in liquid azos. It just works really well. Yeah. Yeah, I mean, you can't beat a liquid as far as feeding it in. With pellets, if you're trying to do like a 0.2%, pellet has to be perfect. Because if you get 2 or 3 pellets and 1, 2, 3, if it doesn't drop it in perfectly, you're going to get some inconsistencies. But man, liquid, you line it out and it just runs so good. So if you're doing profile extrusion, I would highly recommend a liquid azo. Yes, liquid foaming. As far as endothermics, we don't really do a liquid endo. I mean, we're still working on that. It's work in progress, but our azos are good to go. Yeah, but it is an exothermic foaming, liquid foaming. And it disperses quick. It's really good. What's the compatibility with different resins? Well, olefins, styrenes, ABS, PVCs, TPEs, TPUs, TPOs, pretty much, depending on the application, would be endothermics. But this foaming agent is compatible with a bunch of different resins. So like Alkyd resin, ALKYD. I'm not sure what resin that is. But I'll tell you, like I tell everybody else, if it can expand in it, I can foam it. You know, like rubber, right? It's so heavy. You know, big block of rubber. You know, I've tried foaming that in the past, and all they do is put bigger voids because it is conglomerate. It couldn't foam. Thermoset resin. Yeah, thermoset resins typically are a little higher temperatures. They're moisture sensitive, and we've got a high temp product that I wouldn't have a problem adding it and seeing it run. So I think it will work in thermoset. Yep. I just had a guy email me about a TPE application, and foam works well in TPE, works well in TPU, TPOs, acetal. Um, I ran an acetal part, and acetal isn't really extremely, you know, crazy hot temperature, but endothermic just would not do it. But the exothermic did. So anybody out there with acetal, if you want to foam it, we got a product that we can foam it, but it won't be the endothermic in injection molding.
Next question is, any experience using foaming agents on liquid injection molded or compression molded silicone?
No, I've never done that. I've done compression molded parts with foam on liquid injection molded or compression molded silicone. Never done any of that. But hey, I'd like to try it. I mean, I got to see if it'll work, and that's just another thing that I can say that I've done. But I would like to give it a go. And see, with all these materials, I think, you know, with exceptions of maybe some real high temp stuff, but the fillers out there today, calcium is, you know, they got really small particle sizes, and you can drop calcium in it, and you never know it's in the part, but you'll definitely feel the rigidity. It stiffens it up. But again, you don't want to put too much of anything in there. You know, even with foam, you want to put in enough that's going to get you where you want. And really, even in a wall like this, there's only going to be so many bubbles in this wall. And if you try to add more, what'll happen is it'll push to the surface and you'll have splay. So there's a certain point where any more foam is not going to do you any good. None. So you're only going to get so many bubbles in there in an aesthetic part. You try to go higher on the foam, chances are you're going to push it to the surface. So, and even on our website, you'll see a cross section that basically shows you, and the cross section is of this, but you'll see the wall on both sides, and you'll see that gas, the foam agent right in the middle, and it's just really, really nice to see that kind of stuff, which back in the day I could never do. Yeah, no, I'm talking to a customer now that I've done trials, years ago. Well, come to find out, they've added new machines with better velocities, injection velocity, and then we can foam, and because of that injection velocity, we can foam them high gloss surfaces. So, and that's the same company I did a 13% reduction in one particular part. And it was all high aesthetic. Not that it had to be, just that's kind of the way it turned out. Inject at 0.3 seconds with a 7-second cycle. Yeah, I mean, if everybody, if fulminates changed through the years. I mean, if It's not like it used to be. And I was there when it used to be. Now foaming agents, the process I think has gotten, better. I think more and more people are better understanding foam. It used to be just drop it in and they inject slow. Well, that gives you all the splay. Doesn't necessarily mean you get all that foam in the middle. And that's what I call a foam part. Just because it has splay, that doesn't mean it's foam. It just means you added foam. But when you cut the part, you see that foam core, now it's foam. But I've cut in parts where splay was everywhere. I cut them and there was a little bit here and there is gone. So that process is super, super important when you comes to foam. To make sure that you get it in quick, get off of it. Multi-cavitations, that can be a problem. And this is why. Again, calcium doesn't go anywhere but foam. You'll collapse it, you'll overpack it, and it'll go away. So if you got an 8-cavity tool and you have 6 cavities that feel really good and 2 of them, they're a problem child. What happens is when you go to fill those 2, you overpack the rest of them. See what I'm saying? So balance is really, really crucial when it comes to foaming and multi-cavitation. Family molds don't really work with foam unless you've got sequential validation. Then you can just, balance it. Any other questions? Make sure you guys, any questions, ask them. And we'd sure like to, check our website out. Definitely go and, if you want to talk with me about a specific application, just let us know. Let's set up a Zoom chat and we can get that going for you. So, like I said before, foaming agent isn't for everything. It really isn't. I mean, it doesn't work in all applications. But if you really want to, nowadays, with the price of resin and hard to find it, you got to look at trying to reduce that polymer somewhat. And that's why, where's my soda? And that's why we highly recommend you use a filler, some type of filler, talc, glass, just some kind of filler to pull that polymer out. The combination of both, again, works really well, but, again, foam isn't for everything. But calcium, darn near it is, it can do a lot of things for, if you want to hit 5-10% reduction in polymer, 5-10% calcium, and you got it. You got that. Now, depending on, impact, all that stuff that you got to, do with your part, but doesn't mean you got to use a lot of calcium or a lot of talc or any of that fillers. I mean, you can go 5%. It'll add a little stiffness. You'll pull 5% out of the polymer, and you probably never know you even did it. I mean, at 5%, it's a little stiffer, but not really noticeable like 30%. I mean, it's like a rock, but 5%, a little less, but we're just trying to help you people, save some money, because these are tough times when it comes to the plastic world. So we're trying to help you guys either extend your current inventory of material, or maybe material's fine, but you just need better cycles. Well, we can give you better cycles. Calcium gives you better cycles. So definitely look at filling, dropping that polymer with foam or filler, or foam and filler.
Any more questions on the fill it part or foam it part of this presentation?
Calcium, again, you know, calcium will drop your cycle. It does. That's what calcium does. It doesn't drop weight, but it'll sure help on the cycle. And you can pull the polymer out. What's nice about the combination of the two is, you know, the higher you go on fillers, the harder it pushes. But if you add foam, now then it'll push easier, it'll fill easier, and you can take advantage of those temperatures. And I've dropped barrel temperatures off of machines that nobody wanted to see that, but it sure worked out good after that. You know, they're a believer, but it took a while for them to come to grips on that viscosity change. And when I foamed PET extrusion, the amps dropped off the map. I mean, they were just gone. We ended up taking over 140 degrees off the barrel temperature. I mean, minimum of 140 degrees. The line speed increased 14%. They had a compression area that was a heavy mixing area that was shearing. So we had to slow the RPM down to bring that shear temperature down. And yet, when it was all said and done, they were still 7% faster on the line speed. Because once it exits the die, it wants to expand a little bit because it's ambient air. So then it goes into calibration into calibration, and it'll, or when even a sheet, it'll swell up. So you can either adjust the die lip, you can turn the RPM down, or you can just speed the line, speed up a little bit, pull it down to gauge, and take advantage of both the weight and the speed. But I recommend calcium to a lot of customers. We just want to help. That's what we're here to do, is to help everybody in this. When resins are like, prices are like this, and people can't even find resin, we want to help. Any more questions about anything? Anything? Fishing, hunting? But I love doing this. All right, so give me an opportunity to talk to your guys, and I know we can at least do a test. And 9 times out of 10 it will.
We do have a little bit over 30 minutes. If anybody has any more questions or anything to add, we'd be happy to hear it and answer. If not, we will end the Zoom chat early. You know, we're always here to help and answer any questions.
Yeah, we can do this Zoom chat with individual companies. So we can sit down with boardroom so people can get the questions out, and we can, you know, feel a little bit more comfortable about working with it.
I'll make sure to send everybody a follow-up email with this footage once it's on our YouTube page, and with Ron's contact info. So if you'd like to set up a lunch and learn, private Zoom chat, any of that, or want to sample all that different stuff, we can get that going.
Yeah, we definitely encourage you to at least talk to us. You know, I can pretty much tell you after a conversation, is this something you want to do or not? And I'm not afraid to say, you know, hey, look, this may not be the right application, but let's hear it. Let's go through it, and you might be surprised at how many things you can foam and how many things you can fill. I mean, you gotta foam or fill it. That's nowadays, that's your only option.
Any other questions or comments?
All right.
All right, everyone. We very much appreciate your participation, your questions, your comments, for listening to our presentation. Like I said, I will follow up with everybody with the footage and Ron's contact info, and hopefully we can get something going with each of your companies.
Anytime, Connie. Anytime. Yeah, I mean, if you guys check our website out, subscribe to YouTube. You know, we're going to be doing more Zoom chats, and I'll be focusing on, you know, specific applications, you know, injection, extrusion blow. You know, we touch on everything a little bit, but just to kind of hone in on specific applications. So, you guys, look at our website, subscribe, and we look forward to talking with you guys. So, thanks for hearing me.
Thank you, everybody. Have a great day.